This is an intro to break-even analysis. So what is break-even analysis? A break-even analysis is a management tool used to calculate when the output of goods are at the break-even point, the profit, or at the loss. It is to see whether the business is affordable to produce particular goods or service, to work out how many sales are needed to cover their cost, and to see how the break-even point changes as the price changes. To calculate this, consider the diagram below. This diagram here is a break-even chart. The x-axis indicates the output or quantity of the units produced for a business on a certain period of time. The y-axis indicates the revenue cost. We first draw on the fixed cost line. This is always a straight horizontal line since the fixed costs don't change with the units produced. It represents the cost of production that the business has to pay regardless of the product produced or sold. This includes lease cost, rent, and insurance. Next, we have the variable cost line. Variable cost varies depending on the volume of units produced. This includes labor, materials, and supplies. Total cost line is the sum of fixed cost and variable cost. We see that the total cost starts at the fixed cost margin and is parallel to the variable cost line. Total revenue line represents the earnings of the business from the sales of goods or services. This is calculated by the product of price and quantity of the product sold. So when zero quantity is sold, there is zero revenue. Where the total revenue and the total cost meet is the break-even point. This is the point where no profit or loss has been made. The x value shows the break-even quantity and the y value shows the break-even revenue. Anything below the break-even point, where the total cost is greater than the total revenue, is a loss. And anything above, where the total revenue is greater than the total cost, is a profit. Suppose that the present output of the business is greater than the break-even output. Thus, the difference of the two gives us the margin of safety. This indicates the extent to which the existing sales exceed the break-even level of output. The greater the difference is, the less vulnerable the business is to the changes in the market. Let's see how the changes in price, fixed cost, and average variable cost would affect the break-even chart. Our changes will be based under this original chart. Here, we see that the unit price is $6, average variable cost is $4, and fixed cost of $50,000. When the price increases from $6 to $10, the total revenue line gets steeper, and so the break-even point would shift to the left and downwards. Thus, the break-even quantity and the break-even revenue decreases while the total variable cost and fixed cost stays the same. A lower break-even point would increase the chance of making a profit. When the fixed cost increases from $50,000 to $75,000, the fixed cost line and the total cost line would shift upwards. This leads to having a higher break-even point, which means that the business needs more volumes of quantities sold in order to break even, making it more vulnerable for a business to have a loss. When the average variable cost decreases from $4 to $3, this would cause both the variable cost line and the total cost line to decrease. The total revenue and total fixed cost line stays the same. Thus, the break-even point would shift to the left and downwards. Now, let's learn to calculate break-even analysis. Suppose a badminton store sells rackets for $10 per unit, average variable cost of $4 per unit, and fixed cost of $100,000. The question is, what level of output is needed to obtain a target profit of $50,000? Let's observe this with a break-even chart. As you see, the target profit is the difference of total revenue and total cost line. The required output will be the value on the x-axis needed to be produced to get the given level of target profit. When there is no graph, we use this equation. Target profit is equal to total revenue minus total cost. The total revenue is the price of product times the quantity output, and total cost is the sum of total fixed cost and total variable cost. The total variable cost could be replaced with the average variable cost times the quantity output. Now, by plugging the values to this equation, the required output level needed to achieve a target profit of $50,000 would give us a grand total of 25,000 units. Thank you for viewing this presentation.